is simply just the change of energy in a system and is measured in joules, which are also referenced as Newton meters. In order to first understand work, one must understand two basic terms, force and distance. The force exerted on an object can be applied by a number of different sources, including, but not limited to, gravity, friction, and outside sources, including people or machines. This is measured in newtons. Distance references the length in which an object moves, which is measured in meters. Here, I have the equation W equals FD cosine theta. The W stands for work, the F for force, the D for distance, and the cosine theta for the angle above the horizontal for which the force is being exerted on the object being focused on. I will talk more about this angle later in some example problems. This equation is all you need to know in order to do most physics problems regarding work. It is also important to note, however, that like I said earlier, work is equal to the change in kinetic energy of a system or the negative change in potential energy of a system. Simply being, if you change the energy of a system, that change is equal to either the change in kinetic energy or the negative change in potential energy. Now, I will show some videos on work in real, everyday life. Alright, so in order to describe work in everyday life, all I need is a basketball. In order for the ball to travel from here to the ground, there will be a net force acting down on it as gravity. And simply, when the ball drops, that change of energy in the system, the change of potential energy, is known as work. So in this example, let's say I'm trying to move the lawnmower a distance of 4 meters, and that I'm pushing the mower with an average force of 2 newtons, and let's just say it's 0 degrees above the horizontal. In this case, I'd be producing 8 joules of work. Alright, so for the first problem, let's imagine that this tow truck is pulling this box, box thing on wheels, approximately 20 meters to the right, and this thing has an average force of, let's just say 4 newtons to keep things simple. Now, since this rope is at an angle, we're going to have to say that theta here, let's just say it's equal to 30 degrees above this horizontal line here. Now to set up the work, we'll just set up the first equation we learned. Work is equal to force times distance times cosine theta. Usually people put the force and the cosine theta together. So let's sub these numbers in and say 4 newtons times cosine of 30 degrees times the distance 20 meters. Here, we're going to solve for these variables and say that the answer will be 4 times 20, which is 80, cosine 30 degrees. So work is equal to 80 times the cosine of 30, square root of 3 over 2, which is then equal to approximately 69.3 joules. Alright, so since I talked a lot about work, I should also explain to you guys what power is. I'm sure you already know, but power is equal to work over time. In other words, the power of something, usually referenced to machines such as conveyor belts or cranes or something like that, is it lets you know, or light bulbs even, it lets you know how much energy it's giving off in a certain amount of time. Work being measured in joules, times being measured in seconds. Power, the unit of power is watts. Now for a quick example problem of power, of course you could see how simple these might be. Let's say a light bulb is turned on and it gives off, say, 10 joules. And let's say it does this for, 5 seconds. In order to find the power of this light bulb, we would simply plug into the equation P equals W over T and then solve for the power. P equals 10 joules over 5 seconds. Therefore, P in this example would equal 2 watts. And power is a very useful thing, more useful in my opinion than work, at least in everyday examples. And in the future, you will probably see power being brought up a lot. And you should also know that you're not always going to be solving for power in this equation. Likely you could also be solving for the work or the time.